Hello everyone, Bereni Jones here. Today, we'll be deriving the quadratic formula from standard form by completing the square. Now this is the same process you would use to convert standard form into vertex form. Now with this, by completing the square, we're given a squared expression with x inside of it, which we're able to use to solve for x to give us x being equal to an expression with just our coefficients. And that's how we're able to find the roots of a quadratic by using that formula. And this is how we derive it from standard form. Now the first step to completing any square is to factor out the coefficient in front of our x squared from the x squared and from the x. So we want to factor out a in this situation. So we factor out a from the x squared to leave us with x, then factor out a from bx to leave us with plus ba over x. Now that I factor out our coefficient in the first two terms, we now have to complete the square, but I'll write the rest. Now, if you remember, the square of any binomial is just a squared plus 2ab plus b squared. Now, I want that form over here, right? And the way we can find out the missing term is we just divide the coefficient in front of our x by 2, then we can square it. So what that leaves us with is x, so we just write what we have before. And then by dividing this by 2, then squaring it, so we put 2 over 2 on 2 next to the a. So when we square that, we get b squared, and because we have a 2 here, that leaves us with 4 and then a squared. Perfect. But to keep this expression equal, we must subtract the inverse of this multiplied by our coefficient in front. So when we do that, we multiply this by a, we just get rid of the a squared on the bottom, then we flip the sign, which leaves us with minus b squared over 4a. And then plus c equals 0. And now that we have a perfect square, we can convert this into the binomial form, but squared. So, a, and this would be x plus, and then the term we're looking for is just the coefficient in front of x divided by 2, which is b over 2a, and then square this. Then and I'll write the rest. Okay, now that we're left with an x, we can solve for x by manipulating this formula or expression. So we'll move these two terms to the other side. That leaves us with ax plus b over 2a squared is equal to b squared over 4a plus c. And then we can divide both sides by a, and that leaves us with x plus b over 2a squared is equal to b over 4a squared, since we just divide by a again, plus c over a. Perfect. Now that we're left with a square on one side, we can square root both sides. But first, we'll clean up this side so we can leave this as one term. And fortunate for us, we can there's a lowest common denominator. The lowest common denominator here is 4a squared, so we can just make like denominators and then combine the numerators. So what we're left with is if we multiply top and bottom this ca over with 4a top and bottom, we're left with 4a squared and then a 4ac on the top. And we're given like denominators, we can just combine the numerators like this. Perfect. And then we'll square root both sides so that x plus b over 2a is equal to this expression over here. Now the next thing we'll do is we'll clean this up a little bit, and then we will be left with a final expression. So when we move this to the other side, we're given negative b over 2a, then add, and because this, and unfortunately we can screw the bottom since 4a squared is a perfect square, so we can do 2a here, And because square roots have a positive and negative solution, we'll put a plus minus right here. Then keep BA plus 4AC under that square root. And then when we combine these two terms, as we have a common denominator, we're just left with x equals negative b plus minus b squared plus 4a over 2a. And if you are familiar with the quadratic formula, you will know that this is exactly what the quadratic formula is. And we will be able to derive it just by completing the square and a little bit of manipulation. So there you have it. That is the quadratic formula derived from standard form by completing the square. Thank you for watching, and I'll see you next time.